Hello everyone, we are Group 6. I am Mohammad Yusuf bin Hashim along with my groupmates Mohammad Hazik, Mohammad Shafirul, Asil Mohammad, Abdullah and Ibrahim. For this assessment of wind energy, we have chosen Jaisalmer Wind Park, which is located in India. So before we start our presentation, we want to introduce our topic content, what we're going to discuss in this assessment. First, we're gonna introduce you the wind energy and the Jaisalmer Wind Park, the design criteria of a wind turbine, load and application of a wind turbine of the Jaisalmer Wind Park, power conditioning unit of a wind turbine, is it grid connected or a standalone system, advantage and disadvantage of the system. So first let's start with the introduction to wind energy and Jaisalmer Wind Park. So what is wind energy? Wind energy is actually harvested through wind turbines. So wind turbines harness the wind. It is a clean, free and widely available renewable energy to generate electric power. So how the wind turbine works, it's a very simple principle. It have a propeller and have the low speed shaft along with the generator which rotate when the propeller is rotating while the wind cuts the blade. Inside there are a lot of mechanism, like there are brake to control the speed, because the speed of the wind actually determines the power generation. Too much speed is also not good for power generation. We need to we need to keep the speed in optimum level. And according to wind turbine, if we install a 1.8 megawatt, it is enough to produce electricity in a year to feed 1000 average houses. It is estimated that. So we can see that wind energy is actually a very powerful and clean and renewable energy source. Now before we start with the Jaisalmer Wind Park, let's get knowledge about India, where it is located and why India is interested in renewable energies such as the wind energy. So India is the seventh largest country in the world, and it have gross electricity consumption 1208 kilowatt per capita according to 2019. And as 13 November 2021, India have the capacity of 40 gigawatt installed wind power. So it's a big amount, and India is looking forward to make it more larger, because by 2040 the demand will grow by 3%, and India is trying to get the energy, those 3%, from a clean and renewable sources. So Jaisalmer Wind Park actually is not belong to one company or not belong to the government sector. There is private company, and there are a lot of companies those build the wind turbines there. So there are nearly 800 monitoring stations in the wind park, and they are generating more than 1000 megawatt of power. But the country's National Institute of Wind Energy suggests a gross wind potential of 302 gigawatt in India at 100 meter above the ground level. So that was the introduction for wind energy and Jaisalmer Wind Park. Next, my friend will talk about the design criteria of wind turbine.
Hi, my name is Mohammad Shafirul, and today I will be presenting on design criteria of wind turbine. And at first, the original design is called S88, and it's make its own evolution, and now the name the new production design is called S111, which produce more energy from the old design. And as we can see that the design pursue three criteria, which is strong, smart and safe. Which is, the strong is the optimum strength for low wind condition, and also with the larger rotor and higher hub. which could help to extract more energy. Smart technology, which is use the availability wind resources for a profitable investment in wind power, and also by the criteria of safe, which is built for easy and secure operation, which could be maintained for a longer time, and also with the latest design, which is it has 111-meter rotor diameter, and this design could produce 46% more energy from the first design, and also 20% more energy from the design before it, which is S97 at 90-meter height. Next is the design feature of S111. The first features is asynchronous induction generator with 6-pole design and defeat. This design enables variable speed operation and accommodates fluctuating utility demands through optimal reactive power to fit the necessary consumption pattern. And also the next is the DSB54 blades, which is designed and manufactured by Suzlon, and this blade has been tested and proved to be exceeding the industrial baseline, which make it perform much better. Next is six-yaw driver. Six-yaw driver. This driver enables enhanced control, balancing, and load sharing, making this wind turbine much more stable and responsive. The final features is safe and efficient nacelle design. This design helps to make maintenance in much more easy pattern, and this will increase the reliability and also the machine availability, as it in much more easy to maintain. Next is a comparison between the power curve of S97 and S111. It shows that the power curve of S111 increase in much more faster pattern than the power curve. Next we go to load and specific application.
Hello and good day everyone. My name is Ibrahim Al Nuruddin Hassan, and today I'm going to present on the loads and specific applications of the Jaisalmer wind park in India. To begin with, this wind energy system consists of 6 parts developed throughout the time, and mostly are developed by a company named Suzlon Energy. This company is the company responsible in the developing and the manufacturing of this wind system project. So for the part one, we have a turbine made by Suzlon. The total nominal power of this turbines is around 160 kilowatts, and it's an operational and onshore wind farm. And then for part two, we have also turbines that made by Suzlon, and the total nominal power of these turbines is around 904 kilowatts, and they are also operational and onshore wind farm. Meanwhile, for part three, we have turbines made by a company called Gamisa, and these turbines have a total nominal power of 51 kilowatt, and they are operational and also onshore wind farm. And for part four, we have 6 turbines from the company Suzlon, and it's under the model name of S33 slash 350. And power of these turbines is around 350 kilowatts, covers up a diameter of 33.4 meters. And the total nominal power of these turbines are around 2,100 kilowatt, and they are operational and an onshore wind farm also. And then for part five, we have 24 turbines made by Switzerland under the model name of S97 slash 2100, and they generates a power of 2,100 kilowatts, covers up a diameter of 97 meters, And the total nominal power of these turbines around 2,100 kilowatts. And they are operational and onshore wind farm. And lastly, for part six, we have 17 turbines made by Suzlon, and the total nominal power is around 21,250 kilowatts. And they are operational and also onshore wind farm. And these turbines are developed by a company called Hindustan Petroleum Corporation Limited.
Assalamu alaikum, my name is Abdullah and I'm going to present a power conditioning unit for a wind energy system. So starting with the synchronous generators should be used instead of induction generators in direct drive wind turbines. This is mostly owing to the direct driven induction generators higher capacity compared to synchronous generators of the same power rating. Synchronous generators have a set voltage and frequency ratio over rotating speed by design. Variable speed operation has the following benefits over constant speed operation. Charge for solar cell, charger for solar. Starting with firstly, the wind energy collection is improved. Secondly, reduced grid power fluctuations. Thirdly, when the wind speed is low, the turbine rotor makes less noise. The synchronous generator generates variable frequency AC voltage. The voltage must be converted to a different frequency AC voltage for 50 Hz or 60 Hz. Using a cycloconverter design, this AC-AC converter might be accomplished. However, in order to maintain an acceptable waveform, the minimal harmonic content, the cycloconverter input AC frequency, the synchronous generator frequency is limited to around 1/3 of the output frequency, which is the grid frequency. Although it is feasible to choose the number of poles in a synchronous generator to keep it maximum generator frequency below 1/3 of the grid frequency. This often results in suboptimal generator designs. The AC-DC-AC conversion method is preferable over a direct AC-AC conversion. And in this figure, we can see the basic principle of wind turbine power conditioning units for a synchronous generator. And like we can find the fan here, which start moving, so it will produce an AC voltage, then it will be rectified, then it will be to change to DC, then it will be inverted again to AC until it like reach to the output port. Thank you.
Hello, this is Asim representing about standalone wind turbine energy. So this is the overview of the standalone wind energy system. We have the wind turbine, then it's connected to AC to DC rectifier. We have a charge controller here because there will be like a state of charge and discharge between the charge controller and battery bank. And then it's connected to inverter to convert from DC to AC. And then we have the UPS, which is uninterruptible power supply in order to generate high quality of DC. So this is a mathematical model. The output power of the wind turbine generator is a function of the wind velocity at a time step t And the characteristic of the wind turbine generator, such as the cut-in speed, which is V cut-in, and the cut-out speed, which is V cut-out, and the rated speed, which is VR. Then the output energy at a time step t can be computed as follows, as this model. Okay, when talking about standalone system, we think about the system that is not connected to grid. Therefore, we need a battery, and when you have a battery, then you need an energy management. So this is the flow chart. We have the start, and we call the weather data and the load demand. And then here we start to calculate the energy produced from the wind turbine. Then we calculate the difference of the wind turbine minus the load demand. And then we have a condition if it's less than zero. Then we check the SOC, which is the state of charge. If it's equal to minimum, then the energy we have energy deficit. If it's not, then it will be saved. The energy will be saved in the battery. And then we have the other condition, which is greater than zero. Then we check the state of charge if it's equal to maximum. If it's equal to maximum, then we have an excess energy. If it's not, then the energy will be stored in the battery. We normally get rid of the excess energy maybe by having dump load.
Hello, my name is Mama Haziq bin Jamari. So I will present about the impact to society, advantages and disadvantages. So, for the social impact of wind turbines, the social impact is that citizens' health would increase over time. People would not be exposed as many hazardous waste and emissions because people would be moving away from burning fossil fuels and using cleaner, greener energies such as wind power. Another social impact relates to the public's political views. This would play a large part in their choice for energy providers. Liberals would be more likely to embrace the wind energy movement and switch their households' energy supplier. So, we go to the benefits of wind energy systems. First, wind power is cost-effective. Land-based utility-scale wind is one of the lowest-priced energy sources available today, costing 1 to 2 cents per kilowatt-hour after the production tax credit. Because the electricity from wind farms is sold at fixed price over a long period of time and its fuel is free, wind energy mitigates the price uncertainty that fuel costs add to traditional sources of energy. Next, it's a clean fuel source. Wind energy doesn't pollute the air like power plants that rely on combustion of fossil fuels such as coal or natural gas, which emit particulate matter, nitrogen oxides, and sulfur dioxide, causing human health problems and economic damages. Wind turbines don't produce atmospheric emissions that cause acid rain, smoke, or greenhouse gases. Next, we go to the it's sustainable. Wind is actually a form of solar energy. Winds are caused by the heating of the atmosphere by the sun, the rotation of the earth, and the earth's surface irregularities. For as long as the sun shines and the wind blows, the energy produced can be harnessed to send power across the grid. Last but not least, wind turbines can be built on existing farms or ranches. This greatly benefits the economy in rural areas, where most of the best wind sites are found. Farmers and ranchers can continue to work the land because the wind turbines are used only a fraction of the land. Wind power plants owner makes rent payments to the farmer or rancher for the use of the land, providing landowners with additional income. So now we go to the drawbacks of wind energy systems. First, wind power must still compete with conventional generation sources on a cost basis. Even though the cost of wind power has decreased dramatically in the past several decades, wind projects must be able to compete economically with the lowest cost source of electricity, and some locations may not be windy enough to be cost competitive. Next, turbines might cause noise and aesthetic pollution. Although wind power plants have relatively little impact on the environment compared to conventional power plants, concern exists over the noise produced by the turbine blades and visual impacts to the landscape. Next, wind plants can impact local wildlife. Birds have been killed by flying into spinning turbine blades. Most of these problems have been resolved or greatly reduced through technology development or by properly seating wind plants. Bats have also been killed by turbine blades, and research is ongoing to develop and improve solutions to reduce the impact of wind turbines on these species. Like all energy sources, wind projects can alter the habitat on which they are built, which may alter the suitability of that habitat for certain species. Next, good land-based wind sites are often located in remote locations, far from cities where the electricity is needed. Transmission lines must be built to bring the electricity from the wind farm to the city. However, building just a few already proposed transmission lines could significantly reduce the cost of expanding wind energy. So, that's all for the drawbacks of wind energy systems. So we go to the conclusion. Wind turbine technology is growing. The energy balance of wind energy is very positive. The comparison of wind energy with conventional technology highlights the environmental advantages of wind energy. Quite significant emissions reductions can be obtained by producing electricity in wind farms instead of using conventional technologies such as coal and natural gas combined cycle power plants. The significant benefits of wind energy should play an increasingly important role in deciding what kinds of new power plants will be built. With that, I thank you.